Hello, this is Frank. Today I want to bench check this new timer I received. I got it late last night, and it's a timer that was developed by Paul Emerson. It goes under the name Circuit Flyer. And the timer is actually used to control the motor speed, the electric motor speed of a control line model airplane. So it has other functions as well. It controls the delay time, the flight time. It actually can increase the RPMs of the motor if it detects that the plane is climbing, and decrease the RPMs when it's descending. It's able to do this because it has an accelerometer built into it, and so it's actually referred to, I guess, as an active timer. But I just wanted to go over a bench check of it right now before I install it in an aircraft and try it, actually flying it. And I thought I'd go over what I found with all of you. So let's move on to my setup. Okay, here's my setup. This is the timer. I've got the timer mounted on a little board here where I can rotate it up and down in pitch and back and forth and roll. The timer is set up as recommended in the instructions. The instructions are very clear, easy to follow. Assembly was very easy. That's been covered elsewhere, so I didn't include that. But in this case, the board is mounted the edge here parallel to what would be the thrust line, say, of the plane, and the components are facing the pilot and the connectors are facing forward. So that's the timer. For an ESC, I'm using a ZTW 45 amp ESC here. The label's pretty much gone, but it's good ESC. It does not have a governor. Well, it does have a governor, but it's not required. You don't. That's one of the advantages of this timer, is that the RPMs are set by the timer itself, not by the ESC. So it accomplishes that by, if you look at the wiring here, you can see there are a couple leads coming out of two of the wires going to the motor and coming back into the timer. Not sure how that's done. It might be what they call back EMF, but the point of it is you know, every time this set of coils are energized, there would be some sort of feedback back into the timer, and the timer would be able to determine what the RPM is and control the RPM directly and not rely on the ESC to do that. Alright, so in addition to that, what I have here, I have an oscilloscope actually connected to the pulse that's being fed from the timer to the ESC. Normally in the past I've used this little device so that we could look at that pulse and determine if it's increasing or decreasing as the plane is climbing or diving. But for some reason this disrupted things and I couldn't get the ESC to sequence properly with this, so I went to this oscilloscope, which is quite old, but it's able to do the job. So again, what this pulse thing is all about, right? This timer sends out a pulse. It's called pulse width modulation. That pulse goes into the ESC, and the ESC in turn uses that to determine how fast it should cause the motor to spin, basically. So typically that pulse is from 1 milliseconds to 2 milliseconds, and we're going to be able to watch that today on the scope and see how that varies when we pitch the plane up and down and roll it left and right. Okay, so also I have a tachometer here somewhere. Don't know where I put it, but we'll pick it up here shortly. But I put a piece, this is a Cobra motor tube. Sorry, this is a Cobra motor, and it's a 2820-12 970 kV motor, 14 poles. So what I did is I put a piece of white tape on here and then 2 marks here and one 180 degrees from that one. And then that way I'll be able to hold a tachometer on here. My lights are LEDs in here, so their tach is not affected by, you know, the 60 cycles. So we'll be able to see how close we're getting to the RPM that we're asking the timer to maintain. Alright, I think that about does the setup. Let's move on. Okay, so the first time I powered up the timer, it would not boot up properly, and it wouldn't boot up properly because the ESC needed to be calibrated. This is a pretty common thing. Doesn't happen all the time, but if you should encounter it, there are instructions that came with the timer to tell you how to do that. But I'm going to go over it with you right now real quick just to show you how simple it actually is. So if we take a closer look at the timer, right here you can see this little header pin sticking out, and that is basically your switch. By touching that header pin, you alter the capacitance felt by the timer, and it's sensed as a switch press, and that moves it in and out of the various modes. Now you can hardwire. There's a header down here on the bottom, and the directions show you how to do that. You can wire solder a couple of wires there, take those off to a remote switch. And if you're more comfortable with that, you can use the remote switch to change modes. But to get this into the mode for us to do the calibration, I'm going to need to plug the battery in while I'm holding that pin in. And I can't hold the camera at the same time, so I'm going to set the camera down and see how well this actually works out. Alright, I'm going to hold my finger over the pin, and I'm going to try and plug this in. You hear those weird tones? Now I release this, and we get the normal tones. So now the the ESC is now calibrated. So now we can proceed to actually putting the settings in, programming the timer. So we program the timer by using an app on your cell phone. So let me demonstrate how that works. And once again, this is all very clear in the instructions, but sometimes it helps just to see it done for the first time. So the first step here is plug in the timer, the whole system. Okay, we got the proper sequence, and then you can see down here that this little LED is green. So we need to get this into the programming mode, and to do that there are such a thing as long presses on this pin and short presses. We're going to perform 5 short presses, and that should put it in the programming mode. Let's give it a try. 1, 2, 3, 4, 5. And the LED is now changed to a solid yellow, which indicates it's in the programming mode. So at this point then we go to our cell phone. Got a lot of glare here. I'm going to try and move to a different spot here to get away from these lights. See if this looks a little better. Okay, so I've just fired up the app, and I'll give it a couple seconds to locate the climb and dive timer. Okay, it just found it. You saw that little climb and dive, whatever it is, light up here. I'm going to press connect, and now it says we're connecting. So now we're going to use the UART, and you get a blank screen the first time you go into here, but if you hit the send button, it's going to integrate the timer, and it's going to return all the settings, and hopefully you can read those settings. I've got it set for the start time delay for 10 seconds, flight time 60, RPMs are 9600. I've got the climb and dive maxed out to 10, and the number of poles I set to 14 because that's what the motor is. That's what the motor contains that I'm using, and the motor acceleration is set to 5. So if you want to make a change here, for example, let's suppose I want to change the delay time to 12 seconds. So the first thing I would do is notice the line number for start delay is 1. So you would go down here and press 1 and send that to the timer. Now the timer knows that we want to change the setting in number 1 there. Hopefully you can see that. So the next thing I do is simply put in what I want. If I want to make it, say, 15, I'm going to press 15 and hit send. And the timer responds by sending back that number 1 is now 15 seconds. Once you're done making all those changes, you put a 0 in here. I didn't get a 0. Having a hard time doing this with the phone. And then press send. And so that tells the timer that it actually tells the app that everything's good and saved, and now you can back out of here, hit disconnect, and where it says peripherals disconnected, click OK. So at this point then, we now have the settings programmed into the timer. So let's test that. We put 15 seconds into the start delay for the timer. Now, from my determination so far, that 15 seconds, when you first push this button here to start the timer, you hold it in for like 3 seconds, and after that the motor will bump 1 time. And for my calculations, my timing of it, the sequence, the start delay sequence starts right at that moment. So we'll go ahead and see if we can follow that now. So first off, I'm in the ready to go mode. Here's a stopwatch. I've got it zeroed out. I'm going to press the button, hold it in. As soon as the motor started, I started the countdown. And within 15 seconds, the motor should start running. After 15 seconds. Alright, so the next thing let's look at is I set the RPMs to 9600. Let's see if we're actually getting 9600. There we are, 9600. So the timer is able to maintain the 9600 here. I'm moving around a bit. I'm a little unsteady, but there's 9.5. Pretty darn close to 9600. Okay, so the next thing we're going to do is fire this up and try and listen to the motor running, see if you can hear the RPMs increase or decrease, And we'll also take a look at the scope over here. Right now, that is just the steady state pulse that is being sent from the timer to the ESC. It's in the neighborhood of 1 millisecond right now. So I'm going to go ahead and start the timer, and what we'll do is we'll rotate the timer about its pitch. We'll rotate the timer about its pitch axis and its roll axis. Roll axis and pitch axis. And we'll try and get an idea of what's happening to the RPM by listening to the motor and by looking at the pulse width. Alright, so let's give this a shot. Again, we're going to have a 15-second delay here until the motor starts up. And we'll kind of watch the pulse here so you can see when it first fires up what happens. It should increase. Alright, there we go. And now, while we're listening to the motor, I'm going to vary the pitch. Notice you don't hear any change, but if I move it that direction, you do. If I move it this direction, you do. If I do the same thing while you're looking at the pulse, you'll see the same thing. You can see the pulse increase slightly and decrease slightly when I go the other way. So, let me stop this. And let's talk about that for a minute. It may seem a little counterintuitive. You probably expect it to want to see an increase as I pitch the nose up and a decrease as I pitched it down. But it doesn't work that way. The RPM increase comes about when the outboard wing pitches up like that, and when the decrease takes place when the outboard wing pitches down like that. This is also the way the what's the other popular timer that I use? The Fioretti timer. Fioretti timer works the same way. With the Fioretti timer, I expected to see an increase when it went this way and this way, but no, it's on the roll axis. However, the Fioretti timer has another setting called, I think it's called nose up, which is completely different than what we're talking about here. It's just an added boost that when the nose pitches up more than 30 degrees, you get added power. And for that particular timer in that instance, it is using the roll axis to determine that. But for this timer, the roll axis is not being used. We're getting our RPM increase, like I said, when that outboard wing raises up, and we're getting the decrease when it lowers. So I'll fire it up again. We'll just concentrate on the motor when I'm doing that, so hopefully you can see that working a little better. I'm going to have to unplug the ESC just to get things reset before I can try that again. But here we go. Okay, so I've got a hold of this and I'm going to start rotating this. Let's see if I can keep it all in the same frame. I don't know if you can hear that, but it's decreasing slightly in RPM in that direction, and in this direction it's increasing. In this direction it's decreasing. Increase, decrease. Okay, so the other thing right here, you noticed it went to a high RPM. So that was, I only have this set for a 60-second run at this point. So right before the end, I'm not sure how long, probably in the instructions, maybe 10 seconds before it's about to quit, it'll go to full power for a couple of seconds and then it'll turn off. So that is your warning that you're about to shut down. Well, I hope you found this video helpful. For me, the next step's going to be, I'm going to take this timer and mount it on, I've got a P40 Brodact ARF that I haven't used in quite a long time. So I'm going to set this timer up on that and actually do some flying with it to see how it performs under actual flight conditions. So the weather hasn't been cooperating much around here, and I haven't been able to get out anyway for other reasons, but when I can get out I will, and if I can get an update on that I'll put that out, but somebody will probably have something before I get a chance to do it. But anyway, just maybe a quick summary then. This is the Climb and Dive timer. It's inexpensive, and it is an active timer. It doesn't have all the bells and whistles that you'll find in a Igor or Fioretti timer, but it does have some positive things, and the fact that it has an accelerometer in there and can sense changes and give you a boost when you're climbing and decelerate when you're diving might give it an edge over the KR Governor. So that's what I'm hoping to see. In addition, since the timer monitors the RPM directly, the ESC doesn't have to be a very expensive ESC like it does with those high-end timers. And one thing I didn't mention is that if you were to have a prop strike, because the timer is directly monitoring the RPMs, it knows that and can shut down right away, hopefully save you from burning up your electronics and maybe minimize the damage to your plane. But yeah, so in summary, this will allow you to set the delay time, the flight time. You can set the amount of RPM increase and decrease you get. That's set on a scale of 0 to 10. There's another parameter called, we didn't do much about it with this right now, but I think it's called acceleration. But it's kind of, the way I understand it anyway, is ramping up the motor to full speed. You can control how quickly it comes up to speed. And so I think that about covers it. And once again, I hope you find this helpful. And I apologize for the shaky video. I don't do a whole lot of this while I'm holding the camera and trying to manipulate other things. Plus, I'm having a hard time talking. I had some surgery the other day on my lip, and I'm not pronouncing a lot of my words too well. But thanks for watching. Much appreciated, and good luck with the timer. Bye for now.